Hello, everyone. Hey, appreciate you tuning in to hear about 5G Core, the key to monetizing 5G standalone networks. I'm Dave Bolan, and I'm the research director here at Dell'Oro Group for the mobile core network and multi-access edge computing market. And I'd like to share today how MNOs can monetize these networks. What we'll look at, well, I'll make the case for 5G standalone and why you really need this and how you can monetize that because of these new industrial use cases that we see coming out there. Uh, and then we'll make the case for 5G core and why that is so important to monetizing your network with the cloud native technology and what that means to you, the network slicing and edge computing and what that does for you. And where you can apply those technologies is what we call mobile private networks. And this is where you can, over and beyond your enhanced mobile network, generate, I believe, massive new revenues for you. And we'll see that in a few seconds. And then what's behind the scenes to support everything, the Internet of Things, the servers, and the data analytics, the artificial intelligence that makes this all these use cases happen to make sense of all the data that we're generating. And then we'll look at these high-performance IoT use cases, especially the ones in China, where they have kind of, I think, a head start on the industry. So we'll share some of those findings. So first, just to give you an idea of the growth of the industry, 5G core and server market. This is from our 5-year course forecast from my report, the mobile core report, and the telecom server market. And we see here that the edge market is going to grow 80% at a compounded annual growth rate over the next 5 years. And the reason it's growing so fast is because of the demand that we're going to see for these new low latency services that need to be what we call mobile private networks. And as we get out into even further years, we'll see more edge more of the network at the edge than at the data centers to serve that market. And also, it lowers your backhaul costs every time you put an edge node out there because you don't have to take the data all the way back to the centralized data center. There's a win-win scenario there. When we look at the market, China is definitely the driver for this market so far. They have fully embraced 5G standalone, and they launched in mid-2020 and have been going full speed ahead, building out their networks. They're now just finishing up the rural areas, and they'll go back and do densification, probably with small cells, and continue to address the mobile private network. And we'll see how much of it they've already addressed here in a few minutes. When 5G was envisioned, these 5 use cases were defined by the Visionaries. 21, I think it was, maybe 26 mobile network operators got together to draft a white paper and saying, here's what we think 5G should be back in 2015. And those are still the use cases we're looking at today. And they also defined the performance that they thought the 5G network should get over the 4G network, which is an order of magnitude larger than the 4G network. And the same thing with spectrum. We want high speed, more high speed communications, means more bandwidth. And the industry has been very successful in lobbying the regulators around the world or negotiating with the regulators to open up more spectrum to do more things, because we're all learning, especially through the COVID pandemic, the importance of mobile communications, and the rising demand requires us to try and add more capacity to the networks to continue to supply users. And you can see here the difference between the amount of bandwidth that we can provide with 5G compared to 4G. There's a big difference between carrier aggregation and the channel bandwidth per channel versus how many channels you can aggregate together. It's definitely why you need to have 5G for these high performance networks. So if we look at how the industry's been performing, we have 5G core networks out there, 5G standalone networks out there. And they are providing higher uplink capability, which couldn't be done in 5G non-standalone and 4G networks. The battery life has improved for user devices. We got better position accuracy. We have new real-time applications that we can serve that we couldn't serve before. The network user experience has improved for voice and data handovers are quicker, and for voice the connection time is quicker, and it's also, as a user, less buffering connecting to the network. So everything about the user experience is better in 5G standalone that we could get before. And then with the cloud native architecture, we get these new capabilities with low latency, with edge computing, and the mobile private network capabilities with edge-to-edge network slicing, which means you slice the core, you slice the transport, and you slice the RAN as well, giving certain KPIs to each user that subscribes to a network slice. If we look at where we are today, I'll say we have a trickle of MNOs that have launched 5G standalone networks. We've identified 36 of them here at Dell'Oro Group. And the reason I say it's a trickle because there's over 600 LTE networks out there, over 200 5G non-standalone networks that haven't made the plunge into 5G standalone. Now, some places in the world, the spectrum hasn't been available yet for 5G standalone, so that's understandable. Some networks may not have user devices that support their RF channel plans yet, so that's understood. And then some people had to do 5G non-standalone early on because they needed the capacity because the networks were growing so fast. So that's understandable to an extent. But now I think in 2023, almost all those roadblocks will be out of the way, and hopefully we'll see higher upticks. But here I want to help you understand how you can monetize that network if you're ready to make the 5G plunge or 5G standalone plunge. If we look at the network architectures, they're very similar. We have our 5G standalone portion that can be carrier aggregated in 4G and 5G. We have dual connectivity. In the case of 4G, it's dual connectivity. The UE device can be connected to a 4G node at the same time it's connected to a 5G node. That's what we call 5G non-standalone. But the 4G radio is the master, which means all the uplink information, all the uplink data goes through 4G. And that's why we don't get good uplink performance in 5G non-standalone. On the downlink side, though, you get the combination of the two radios combined to get that downlink performance. On the 5G side, that dual connectivity can be between the low frequency and the millimeter wave band, providing that 1.2 gigahertz of bandwidth potential between that is capable in 5G spectrum plans. And then, of course, you have the carrier aggregation as well with the 5G carrier aggregation if so need. So at this point in time, if you ignore the spectrum applications, these networks look familiar or similar, but the difference is in the 5G core. What makes the 5G core different is the cloud native technology. What's also, well, I'll get to that in just a second, but also we have this service-based interface that allows every network function to talk to the other network function. So the network exposure function makes sure through the service-based interface that every other network function is aware of all the services that are on the network through the control plane. And with the control plane and user plane separation, we now can have user planes at edge sites. And that helps us give us the lower latency capabilities by moving the user data to the edge site and doing all the compute and data closer to the RAN sites. And with the network slicing selection function, that's where we get our network slicing. And all these networks, I should point out, are cloud native network function. Container-based cloud native network functions, which means you can enable microservices. And we'll see an example of that here right now, actually. So network slicing allows you to slice the RAN, and the core, and the transport, as I mentioned. And you can have network slices per these 5 predefined use cases that we just reviewed at the beginning. or you can add additional refinements to those, or define your own with the KPIs for what speed you want to guarantee, what data throughput, what latency you want to guarantee, jitter, and other characteristics that you might want to define. But you can also define it for a certain point in time. In like a public network slice on a shared network, like it's done here with Singtel. They were the sponsors for this Formula One race, the Grand Prix season Singapore 2022 in September and October, where they have an app called Cast, and they provided a network slice for that during the race time, 10 Singaporean dollars for the week for the users. They expected over 250,000 fans. It turns out 300,000 fans showed up. And you could have the user experience of seeing different camera views in action, no matter where you were sitting, no matter where you were on the venue for the week of the festivities, also around the Formula One event. And this was a new application of network slicing that we hadn't seen before. So this was a good example of network slicing. As we know, edge computing, we mentioned, the closer to the RAN site, the better the latency. And you can put the edge site right on the enterprises. So what we call public MEC is shared, for industrial use cases that need broad geographic coverage, drones, smart grids, vehicle to everything, public safety. Maybe logistics companies have some real-time low latency requirements. And then private MEC, where they want to have the data on site, and we can put the enterprise. We have the RAN on site, and we have the edge on site, the mobile edge compute right on site, giving us the lowest latency, and data sovereignty, protecting that network. And up here, we're using network slicing to protect the data and make it a virtual private network for the industrial use cases. An example here of edge computing is computer vision, enabling quality inspections, textile manufacturing, making polyester fibers. So we got the camera up here on an arm, an AMR, an autonomous mobile robot, acronym, that moves around and does the quality inspection as needed as the machines are running at 4,000 meters per minute. The camera is running at 8K video, and the performance has been met that needed 100 megabits per second uplink, again, which can't be done in the 5G non-standalone or 4G networks with the low latency requirements to keep up with going at this speed. So how do we size the network? We call it mobile private networks to go after these industrial use cases. But they can also be consumer use cases. They don't have to be restricted. So mobile private networks doesn't necessarily mean industrial use cases. It can be consumer use cases as well. And we'll talk about a few of them in a minute. So as I mentioned, closer to the edge site, we see 10.5 million RAN locations or macro base stations by 2026. And we see the network maturing to that point in time sometime in the future. It may not be by 2026, but it gives you an idea of the magnitude of the size of the network that it would take to do that. But when we get into vehicle to everything and mission critical services, they're going to want that kind of latency. And of course, we'll do that in the bigger cities probably first and continue to go out to the rest of the network over time as the networks mature. So that gives people that need the shared geographic experience with low latency experience and still have network slicing for KPI, performance guarantee, capability on the shared network. Now when we get to on-premises of an industrial location or a venue, we have dedicated where the edge is on-premise, and standalone where the RAN and the edge and maybe the 5G core are all located on premises, not attached to the public network. They may have their own frequencies that allow them to do that, but that doesn't mean that's not a market you could address. You could still go after this market because it's a lower cost solution if you provide an on-premise mech and still do the cloud computing for them than them doing everything themselves. Or you can help them bring those solutions to them in the network and build it, help be the system integrator and be the supplier to that. So you can also address that market. And here, 14.5 million locations compared to 10.5 million over here. And you can see why everybody's focused on this. This is new territory that hasn't been addressed. And it's a large market opportunity for you to monetize. And the way you monetize that is with IoT connections. And how big are these IoT connections? So this is a forecast of the cellular IoT connections. So this is just 4G and 5G connections, but 60% of 5.5 billion will be broadband IoT. These are these new high performance IoT use cases that we're talking about. And these won't be $1 or $2 a month or $6 a month revenue IoT connections. These will be maybe 10 times that. When we think about, okay, an IoT connection that can do 100 megabit per second uplink capability, that doesn't come at $1 or $2 a month. So your ARPU, if you will, for IoT devices, for high performance IoT devices, will be much higher that you can monetize. Not only do you monetize the connectivity on an ongoing basis, but you can monetize the use cases. It's you bring those solutions to the mobile net, as a mobile network operator to the industrial users. So what does it take to make this all happen besides the 5G core and the 5G RAN? Well, we have to have IoT devices, and there's the typical IoT sensors that we've had in the past. There's some newer, more sophisticated sensors that are a little bit higher data throughput that will feed some of these devices, what we call high performance IoT devices. And we're just looking at the end users of this, but not all the technology that makes these high performance IoT devices, like high resolution cameras, augmented reality glasses, and then a plethora, if you will, of autonomous vehicles, whether they're automated guided vehicles shuttling parts and inventory around in a factory, or autonomous mobile robots going around and doing computer vision, surveillance, or drones doing inspection of a geographic location. For MNOs, inspecting towers with drones, your radio towers, and then off-road vehicles and on-highway vehicles. Vehicle to everything, V to X. So to make all that happen, you're going to have high performance servers. And so we're going to, you need to look at the CPU technology, the GPU technology, the NPU technology, and the VPU technology that makes this all happen, for the artificial intelligence that's going to need to be processed on there, and the data that needs to be processed to make sense of all the data that's being generated, and putting that compute power closer to the end users. And then the user plane function, data throughput is paramount as well for these high performance IoT devices, to not only analyze the data quickly, but to get the data in and out quickly as well to the servers. And there's different acceleration techniques that can be done in the user plane function. And what's really nice about these new generation of servers, they're still more energy efficient because they keep going down in CPU, down to 4 nanometers, 3 nanometers, whatever they're getting down to, in the size of the circuits that are on these devices now, continue to make them more energy efficient. And when we get over to artificial intelligence and machine learning for the data analytics, we're now into real-time analytics with predictive analytics that you might get in for actually network analytics, predicting something before it happens, to do predictive maintenance from the sensor data that you're accumulating on equipment, prescriptive analytics, trying to prescriptively analyze what could happen with like digital twin technology that's being developed out there. So this requires very sophisticated AI and ML algorithms being analyzed with a lot of raw data quickly in the petabytes range. So it happens quickly. So when we look at high performance IoT use cases, we looked at what we call top industrial use cases, where you can use computer vision for a lot of these applications, because computer vision does enable them, and we actually call computer vision the killer enabler app. And where can you use computer vision? In quality control, in your surveillance and your security, with your facial recognition, iris recognition, retinal recognition gives you a lot of security capability. Going around on mobile robots for mobile surveillance, or even permanent mounted cameras with using image detection, object detection, gesture, event recognition, and using all that AI capability to know what's going on with your surveillance, with your facility for security. Maintenance troubleshooting with AR glasses, same thing with AR glasses for employee training, where it shows and guides either the maintenance technician or the employee how to troubleshoot or operate the equipment. And then these automated guided vehicles for shuttling inventory around the plant, and computer vision for remote equipment operation, where you need to have high resolution cameras to be able to make sure everything is happening as it's supposed to happen. So we don't have time to go into all this, but if you look at all these capabilities, you can think of a lot of applications that can be done with computer vision. And this is high performance. So what are the lessons that we've learned from China? Here's a few examples. I got 8 examples here to share with you. Sand and heavy industry doing material handling with augmented autonomous guided vehicles or automated guided vehicles. They used MECA network slicing that was applied by China Telecom. They did over 200 AGVs with computer vision, and you can see the performance here with a 90% cost savings. Over here at Jingtan Iron and Steel, 120 cranes were modified for remote control operation, and using MEC and computer vision to control these cranes, and they got a 25% efficiency improvement, where one operator now can operate 3 cranes simultaneously. At the Tianjin port, they also did smart cranes too, but I'm trying to just highlight one use case per user here, but they are using multiple use cases. Here they're using unmanned container trucks with computer vision to shuttle the containers around the plant. Instead of an automated guided vehicle, they're using unmanned remote control trucks moving the containers around. And you can see the experience that they've had in doing that at the time that this report was made. The GSMA has done an excellent job of cataloging all of these use cases. And this is just a brief sample. Smart grid application, China Southern Power Grid, using network slicing and MEC on a public MEC network, using drones with infrared sensors with computer vision. And look at the performance increase, 80-time efficiency improvement on transmission line inspection, 2.7 times on substation inspection, and from minutes to milliseconds in fault isolation. These are some fantastic productivity increases that as an MNO you can bring to the users. And these are MNOs these are users that'll be satisfied, they get their return on the investment, and you'll get your return on investment because you get to have the ongoing subscription service and high IoT revenue subscription services for these high performance IoT devices. Gina Technology doing quality inspection, surface inspection on molded metal parts, like the housing on your smartwatch, your smartphone, your tablet. You may have a device on your arm that was inspected with computer vision with 99.96% accuracy. It did it 30 times faster than the manual inspection of people sitting there under a microscope, manually looking at these parts to see if the surface met the smoothness and quality that's expected by end users. And in this particular factory, that was 50% of their labor was doing the quality inspection. So a huge productivity improvement. Media appliance division, major appliance manufacturer, using MEC, supplied by China Telecom, again using computer vision. Here I categorize just the 7 use cases that they had under one roof. They got a 17% increase in operational maintenance efficiency and a 10% reduction in operational maintenance costs. Xiamen Transportation Bureau, autonomous buses. You can see all the different use cases that they have here and things that the technology that they implemented. They did this through a very concerted effort with proof of concept to make sure everything would operate properly with 2 buses. It had over a 60 kilometer route, 16,000 kilometers of travel time, and it was successful. And now for over a year now, they've had 50 buses in commercial service, and they are on dedicated roads. But when you get to the 5 major intersections that that bus route goes through, they upgraded those with LiDAR detection LiDAR vision technology, with computer vision, and roadside assistant units to make sure that the autonomous buses can navigate safely through the intersections as well, and not just on the dedicated bus lanes. And here's a consumer application, Magoo Interactive Entertainment, cloud gaming, using the network, the public MEC nodes that China Mobile has installed with network slicing. And it met the performance requirements for 4K HDR at 60 frames per second, not just 30 frames per second, the low latency requirement and the speed requirement. So to me, this is impressive results that we see. And my takeaway from these lessons are, it's most important that you stay focused on the top use cases that can be leveraged across industries. Almost every factory needs quality inspection, surveillance, training. All these can be, transferred from one factory to another, and you can scale and replicate these and get a big return on investment for you developing or partnering with solution providers and making this happen, and having a catalog of solutions that your marketing department can go after and tackle these networks and sell these networks. And that's where China is at. Everything's cataloged now. They know the pricing, the performance, and the marketing and sales teams are out there selling these things out of a catalog now. That's where you want to get to and replicate these use cases. And also pay attention to use cases where the user's willing to pay a premium for better performance. Driven primarily by latency, which is what we see in cloud gaming, which has been a big success as well in enabling cloud gaming for 5G or 4G user devices. Because it's also important that the 5G core, it can also do the 4G once it does the 5G. So, you have converged cores is capable as well. And the note of caution. Make sure you don't chase a lot of 5G use cases. Could be one-off. Can you leverage it or can you not? And China learned this early on. They developed a lot of use cases that they're not promoting anymore because there's just not a big enough market for it, and they're not going to get a return on the investment. So be careful on that. Do your due diligence and make sure you're doing use cases that can be leveraged. And that's what I tried to highlight here today. Now, what's the success China has had? This is impressive as well. The 3 service providers, the MNOs in China, have signed over 28,000 contracts to do mobile private networks over the last 3 years. And they've implemented over 5,000 of them to date. These numbers are mind-blowing compared to what I have seen in the rest of the world. And a lot of the rest of the world is still doing proof of concept. And China has almost commoditized this at this point in time. So I think we have a lot to learn here. What was released in their interim reports for the first half of 22, China Mobile now has well over 300 public MEC sites that those cloud gamers can take advantage of to get that low latency. and the high data throughput that they want on the 5G standalone network. The revenues for mobile private networks at China Mobile were up 223% year over year. They're starting to reap the benefits of those early deployments and replicating them across all the networks. The sales and marketing teams are in full force. China Telecom, just in the first half, 1,300 new mobile private network contracts. Revenues up 80% year over year in the first half of 82. Now, they don't tell us how big those contracts are, but China Unicom gave us a little sneak peek. $500 million, and it's well over $500 million. I just rounded it down for conversion purposes, just not to overstate it. $500 million in new contracts in the first half of 2022 was signed, and they've already completed 2,000 contracts. So you go back to that 5,000, China Unicom has the majority of them almost. So what's the takeaway there? The Chinese MNOs, I think you can safely say, have learned how to monetize these 5G standalone networks, leveraging the 5G core into these new markets. And I think that's something that every MNO can do to monetize their networks. So I want to thank you for your time and attention. And I hope this provided value to you. Have a good day. Thank you very much.